Okay, so in the example, which we should get started with now, sorry. All right, so it says this: copy and complete the table of values for y equals 2x plus 5. So we have a table that says that goes from -3 to 4 for x, and then we have to find some things for y. So question A says, use a scale of 2 centimeter to represent 1 unit on the x-axis and 2 centimeter to represent 2 units on the y-axis to draw a graph of y equals 2x plus 5 for x is between -3 and 4 and also equal to them. Question B says, using the graph, what is the value of y when x equals 1.8? So that's what we have and we need to solve. So let's see how we can go about it. So the first thing, like I said now, the first 3 things you need to do before you can plot a graph is that the first thing you need to do is define the values. So of course, what you are plotting, you are not plotting any other thing other than the values. So you are plotting the values. That's number 1. Number 2, you are giving the title, and you are drawing, you are deciding a scale as well, which you are going to also write down. So the values, the title, and the scale. Values, title, and scale. So that's the first part of this question. Now we need to write what those values are by making use of the function that has been defined for us. So that's the first thing we'll do there. So now the second thing is to decide on a scale. Luckily for us, they've given us a scale that we are going to use. They've given us a scale here, so we are going to make use of that scale to solve our to draw our points, to do our graph. So we don't need to think because they've given it to us. So we use what they've given to you. If you are not given anything, you have to decide for yourself what an appropriate scale should be. Then the next thing to do is to answer questions based on the graph that you have plotted, and that's what we're going to do with this example. So the first thing says that we need to copy and complete this the table of values. So let me just do it somewhere below, so I don't do it where the question is. So let's see solution. Okay, so now we have let's see, we have x. Since this one is simple enough, there's no need to split it. Let's just write y straight away. So we have -3, -2, -1, 0, 1, 2, 3, and 4. So now we need to make use of the equation they gave to us to get what y is for those different values of x. So in the first case now, the equation is y equals 2x plus 5. So we are going to say 2 times x, 2 times, in this case it is -3. 2 times -3 is -6. -6 plus 5. -6 plus 5 is -1. Okay, so 2 times -2 is -4. -4 plus 5 is 1. This is 2 times -1. That's -2. That's going to be a 3. This is going to be a 5. This is going to be 7. This is going to be 9. 6. That's going to be 11. And 2 times 4 is 8. 8 plus 5 is 13. So this is our values. So we have ranging from -1 to 13. -1, 1, 3, 5, 7, 9, 11, and 13. So that is the values we are going to be plotting for our graph. So now the next thing to now do is to come to the graph page now. So that's where all the action is going to take place. So now it's a note of warning to you. The only thing you have to make use on your graph is a pencil. Don't write biro on your graph because you may want to make changes. That's it. So for me, I always recommend writing the title first, because of course the title is not something you need to think about. So that's just what you just have to do here. So you can just say a graph of y equals 2x plus 5. So we've done that there. So that's the title of the graph. So we've written that well. Okay, so now the next thing to do is to draw the scale, to write the scale. So depending on what it is now, you may just I can just easily write what they've given to us immediately. But sometimes you may want to draw your axis and then see, okay, well, let us see how it works, because it is when you are drawing your axis you'll be able to decide what scale you are going to use for your graph. So, but in this case they've given us the scale already, so we can just easily just quickly write it down. So we can just say, okay, 2 centimeter to 1 unit on x axis, then 2 centimeter to 2 units on y axis. So that's what they've told us now. So that's what we are going to use for our graph. So I hope this works very well, because I know this might be a little bit tricky to film for this thing, but yeah, let me just focus on the main page down for the graph. So that's what we have there, right? So now we're just going to focus on the actual graph now. So now the first thing you need to note is, how are you going to draw the distance? Where are you going to place the origin? So the origin is where your horizontal axis and your vertical axis they intersect. So I could draw it this way now. For example, I could always, when you start it in a very elementary class for graph, you will see that they place your origin at the center. And let me see, I have my eraser here. Let me just do something so you can quickly get the point of what I'm trying to do here. So we can just draw our origin. This is a naive origin, so I'm not expecting it to be there, but I just wanted to make a point. So you draw your y-axis, and then we can also draw our x-axis somewhere at the middle, so somewhere here. So I don't know if this is going to work optimally for this graph, but I just wanted to make a point. Then we can erase it and start over again. That's the advantage of working with a pencil. So now I've drawn my origin now. So the origin, the axis, the y-axis and the x-axis, you need to label it. But since I've not decided, I don't want to do so now. So we could place this as a 0. You can place this place is going to be 0, the starting point where both my x and the y is 0. Hopefully that's the middle of the graph itself. So the thing is, you want to like try and fit the values you have, your x and y's, into the graph in such a way that the scale allows the values to spread out on the graph page. You want to consume about 3/4 of the page, like 75% of the entire page with whatever you are plotting. You don't want to plot something and everything is compressed to a very small point here, or a small point here, or a small point here. That's not efficient. You need to at least let things spread out so that you can see in between. So that's why choosing your scale is very, very, very important. You need to be able to choose a very suitable scale like that. But let's still go on. That's not things for you to worry about yet. But what you should worry about now is that how your x and y should spread out. If you look at it here now, I have y, my x is between -3 and 4. So we could just say, okay, this is 0, so that's -1, -2, -3, because that's what the scale told us. The scale said we should take 2 centimeter to 1 unit. So each time we go by the big red box, by the bigger box, we go by we go by 1, right? We go by 1 unit. So 0 is here, so we go by 1, 2, 3, 4, 5. As we go to the right, you are going to the positive side of x. We go to the left, you're going to the negative side of x. So this is 0, -1, -2, -3. So based on this already, I can see that it captures everything that we have for x. It goes from -3 all the way to 4. So as you can see here, this is -1, -2, -3, -4. So I guess I'm good. And here I have a 0, 1, 2, 3, 4, 5. So in terms of x, I guess we are good. But if you check the y, now that's where the problem is. The y goes from -1 all to 13. So even if you are going, and then it says we should go 2 centimeter to 2 units. 2 centimeter to 2 units now. So if you go from 0 now, if you go for 13, this is going to be 2, because 2 centimeter to 2 units. So you are going from 0, that's 2, 4, 6, 8, 10, 12. So once the highest point that you can have for y is 12, and here you can see it stops here at 13. So that means we are not going to consume all the pages that we have because of our y, all the values that we are given. just because we don't have 13 there. And then if you look at the negative side of it, it just says -1. So your negative only just needs 1 point, like they say, just 0 to -2. So all of these places that are down here are not even going to be consumed by our graph. So that means this is a case where our axis is not properly labeled. I wanted to say it, but I wanted us to go through the entire thing together. I wanted you to see how the axis is being decided. So some cases they will tell you to just put it at the middle, but in many cases that would be the wrong thing to have done, right? So we need to erase what we see here and then choose a more suitable place for it. A more suitable place to put our axis could be somewhere around here, so that a lot of space is given to the positive y's. As you can see for our listing, a lot of places for our positive y. Meanwhile, our negative y is just having just a little bit of space. I mean 0, -2, -4. I guess that's good enough for it because it stops at -1 anyway. And then also our x, I think I will be more concerned if I just shift it somewhere, maybe just 1 bit here. So it goes from -1, -2, -3, -4, something like that. Let me just do that. But it doesn't matter it's not a thing for you to be overly concerned about. Okay, it has to be in a particular place for your axis. No, the truth is that it is an art. It's not a science, in the sense that it could be anywhere as long as it picks all the points that you need it for. That's what matters. So the decision I am making is that I'm shifting my scale to the left and I'm dragging it down. So where's my ruler? Let me just quickly do so. All right, so like I said now, it is an art, not a science. So your graph doesn't have to exactly be like mine. You just have to follow the general principles. So you need to just pick all the points. So the next thing you just do is to label the axis. So the label is by doing this. So this place is your x, this place is your y. So you put it down as such. The next thing is to put your values to it by following the scale. So let me start. This place is going to be 0 because that's the origin. So you start by saying, oh, it says 1 centimeter on the x-axis. So this is 1, 2, 3, 4, 5, and 6, like that. Though I wonder how visible it is showing on the video, but this is -1, -2, -3, -4. Okay, so on the y-axis, remember that it says 2 centimeters to 2 units. So we need to actually like follow that as well. So each of the bigger box will take 2. So this is going to be 2, then 4, we have 6, we have 8, we have 10, we have 12, we have 14, we have 16. So I can stop there because, I mean, after all, my values stop at 13 anyway. So on the negative side, I have -2 and -4. So that's that. Yeah, that's how it works. So the values may not be showing, so the thing may not be showing so well because the light and this shade of pencil doesn't agree so much, but no, that's how it works. So now that you've done this, you've done majority of everything. I mean, you've done like, well, 40% of what's needed, and every other thing you will do will really appreciate from what we just did. So you've labeled the title, you've written a title, you've written a scale, and you've labeled your axis. You've drawn and labeled them. So the next thing for you to do is to start plotting. So when you are plotting now, you need to really pay attention to the values you are picking, and those boxes in between anyway. So let's pay attention to what we have here now. Let's try. So the first point is to say -3 on -1, -3 on -1. So -3 is on the x and -1 is on the y. So let's see. So this is where it is. This is -3 for x. Now you need to decide where -1 is for y. If it had said -2, that would have just been here, where the two of them intersect here. But you realize that this is in the even numbers now, So you need to now understand that, oh, if from here to here is a 2, now, if each big box is a 2, where will 1 is going to be? So you have to say, oh, how many small boxes now make up this thing, this big box that we have? The answer is 10. So if the entire thing is 2, if the entire thing is 2, is 2, you now, each small one, 2 divided by 10 is going to give you 0.2. So that means when you move through each of the smaller boxes now, you have your 0. You get 0.2, and that's how you find your way to 1. So if this place is 3 now, this is 3 for x now, on this side this is 3 for x. So where's your minus 1 going to be? You start counting it on the vertical side of it. So this is minus 3, Abby. So you need to count 1, and that's going to be 0.2, 0.4, 0.6, 0.8, and let's see, 0.2, 0.4. Let me see very well. So I have 0.2, 0.4, 0.6, 0.8, and 1. So that's fifth one. I don't even know if I'm counting this well. 0, 0.2, 0.4, 0.6, 0.8, and 1. So you draw a small tiny x around that point. So let me count the remaining one. It's going to be 1.2, 1.4, 1.6, 1.8, and 2. So that's how that works. So you draw it well, and then you zoom. Let me zoom on it a little bit so you see what we are saying here now. So the way it works is that you count it. Now let me count on another line that is not this thicker one, so you see it better. So this is what 0. This is 0. So minus 0.2, 0.4, 0.6, 0.8, and 1. You count it. You have to be careful when you are doing that now. So if you see it, that's exactly where I drew that first one. You need to get it very well for that. So let me zoom out. Okay, let's go on. So now the next value you have to plot says minus 2 on 1. So minus 2 on 1, minus 2 on x, 1 on the y. This is minus 2 on x. So let's count for 1 there now. So that's going to be 0.2, 0.4, 0.6, 0.8, then 1. So you just draw it there. Okay, so we could draw it as an x, as a cross, or you could also use a dot. I think, well, I'll prefer you using a dot. So let me change the ones I've drawn, this one to a dot there. So you just see it's smaller, and it just picks the points easily like that. So that's how that we have that. So the next one is minus 1 on 3. So minus 1 will be on 3. So again, you go to where 2 is now. You count your 3 from there. So it says 2.2, 2.4, 2.6, 2.8, then 3. 3 has to be there, right? You can see the points now. So that's how we pick that point as well. So the next point says okay, we've said minus 1 on 3. So the next one is 0 on 5. So this is the 0 on the x-axis now, and you need to go to 5. So this is 4 now. So we have 4.2, 4.4, 4.6, 4.8, then 5. So that's how we have that there. So that's 5 now. Now the next one is what? 1 on 7. So 1 on 7 now. 1 on 7. So this is 6 there. So okay, 6.2, 6.4, 6.6, 6.8, then 7 is there as well. So that's 1 on 7. Now the next thing is 2 on 9. 2 against 9. So this is 2 now. We need to get where 9 is. So that's 8. This is 8, Abby. So we have 8.2, 8.4, 8.6, 8.8, and 9. Okay. Now next one is 3 on 11. 3 on 11 is, this is 3 here. So we have to go to 10. So 10.2, 10.4, 10.6, 10.8, and 11. So that's where we have that. So now the last one hopefully says 4 on 13. So this is 4, and you can see this is 12 now. So you go 12, Fabi. So you go 12.2, 12.4, 12.6, 12.8, then 13. So now we've picked all the points that we have now, and you can see it uses a considerable part of the page. Now it doesn't go all the way up fully, it doesn't consume 100% of the graph, but I mean it's pick enough points that at least that makes sense. And besides, that is the scale the question gave, so you don't even have any choice. But when you have a choice, you need to pick a suitable scale that uses enough of the points, enough space in the graph. So that's what we have to do for that. So we've picked all the points. Now the next thing to do is to connect them all. And how do you connect points? You look at what you just plotted and you draw it closer to the closest to what it is trying to represent, to pick all the points. Now in this case now, we are likely going to have, not even likely, we are going to have a straight line graph, a straight line that touches all the points, and you have to try as much as possible to draw it at one go. So the reason why at one go is because so that you don't draw multiple lines, because the line is supposed to represent something. So you need to get the ruler that is just quite long enough for the entire thing. In this case, my ruler is not long enough, but I'm going to do it in such a way that at least it makes sense anyway. But that's what I'm going to do. So, but the reason why we are going to have a straight line graph is because our equation is a linear equation. The highest power of x is 1. Whenever you have the highest power of x to be 1, you have a linear equation. So let's quickly draw the line now. So you pass your ruler across all the points. In this case, my ruler can't reach all the points anyway. So let me just pick. Okay, I have majority of it here, so I just have it, and I will just draw the line across them all like that, in one sweep like that. Now I've passed it across that, it remains the last one, so I still have to follow it like that so that it touches the last one like that. So you can see, and I may even want to extend it as well beyond what my graph is saying, because I mean that's a straight line graph for you. I can just have the straight line like that, so I can just still extend it like that. So that's what we have for our graph. So now I've plotted it. That is what we have for our straight line graph. You can see it's a straight line that goes from there. Now we've plotted the entire thing now. And that's how to plot a graph. We've answered the question A. So in the next section, we'll answer the question that they asked us to solve from there, which is finding a particular value from the graph that we have plotted. But as a checklist, let's see. We wrote the title of the graph. We wrote the scale. We labeled the axis y and x. We gave the numbers to the axis, and we use it to plot our graph. So you may be wondering, this one that we did now, that we had to be seeking for values in the middle of the graph or somewhere else, not at the defined edges for your y, for example, would you always have to do that? Well, the answer is no. It depends on the values you want to plot. It is your values, your axis, that will decide what you are plotting. Or you just need to understand that each tick red, each tick line here is 2 for me, for this particular book I'm using. So each smaller one in between has to be 0 points. It has to be whatever you use as the distance now, divided by 10. So I mean, in the sense that in this case here now, for this particular graph now, we went from 0 to 2, and I realized that there are 10 boxes here. So that 2 we divide by 10. So each one of them is going to be 0 0.2, 0 0.2, 0 0.2. If it had been 5, that was my scale. So that's 2 centimeters to represent 5 units. If this had been 5, for example, I will say 5 divided by 10. So that means each line is going to be 0 0.5 each. If this had been 10, for example, like 2 centimeters represent 10 units. So this is 0, 10, 20, 30, 40, like that. I'll say 10 divided by those 10 lines, and that will give me 1. So that's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A trick I always use is that once I track from 0 to this number using that smaller scale, and I arrive at the number by here, that's how I know that I have done the right thing. So if this had been 10, not 2, that you are currently seeing there, and that means each one of it has to be 1, 1. So that would have been 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So you can see it follows, it tracks well. So that's how that works anyway. So that's that on this graph. You need to watch this video and really understand it again. So I hope everything is well understood. In the next section, we answer the question B that they asked us to solve from the graph. So until then,